Okay, we're back. So in chapter 9, we learned how to solve quadratics, but now, and that was x's with the squared, so we learned how to solve something with like x squared is equal to a number. And unless it had that x in the middle, in which case we factor to use the quadratic formula, we could just take the square root of it, and this would cancel, so you'd have x is the square root of whatever that number is. Well, now we're going backwards, and we say, what if we have the square root of x is equal to a number? How do I get that poor x all by himself out of the square root? Well, the answer to that is going to be squaring everything. Because then remember, a square will cancel out a radical, so then you'll have x equals whatever that number was squared. Maybe this will make a little bit more sense when we try a problem. So what if I have radical x equals minus 5 equals 0? Well, before I can square both sides to get rid of the radical, I need to get the radical x is equal to a number. So I need this to be alone. Okay, on one side. You need the radical to be alone. So before I can do that, I need to add 5 to both sides. So that gives me radical x equals 5. Now, to get rid of the radical, I can square both sides. So I can square radical x, and I can square 5. So a radical and a square cancel out, so I just have x, and I have x equals 25. And you can check by plugging that in. And our original equation was x, or radical x, so radical 25, minus 5 equals 0. Radical 25 is 5, so 5 minus 5 equals 0. And it does check out for us. Okay. Let's try a little more complicated one, but the same idea. We want to get this radical all by itself. Until we do that and get all this 3x minus 6, right now it's trapped. It's trapped in the radical, and so we can't do anything to it until we get rid of the radical, which is after we get it only that on one side and then square both sides. So my first step is to subtract 4. Now I have the radical by myself, so I can square each side. So I'll square radical 3x minus 6. And the radical and the square will cancel out, and I'll square 4. So that gives me just 3x minus 6. What was originally under the radical is now out, equals 16. And now I'm going to solve it just like I did in chapter 2. Easy peasy. I'm going to add 6 to both sides. That gives me 3x is equal to 22. Now I'm going to divide by 3. Oh, and Miss McMillan made a mistake. You guys probably caught this. That's why this isn't working out for me. What is 7 minus 4, guys? It's definitely not 4. It is definitely 3. So let's fix that right here. My apologies. So I subtracted 4. 7 minus 4 is not 4. 7 minus 4 is 3. If only Miss McMillan knew how to edit better. 9 plus 6 now is 15. 15 divided by 3 on both sides will give us an x equals 5. So our solution is x equals 5. So to check that, we had radical 3x minus 6. So 3 times 5 minus 6 plus 4 equals 7. So that's radical 15 minus 6. Plus 4 equals 7. This will be a radical 9 plus 4 equals 7. Well, radical 9 is a 3 plus 4 does equal 7. So that checks out for us. You can also do a quick mental check in your head if you want. You don't have to write it out. Sometimes, though, it'll give us 2 solutions. And if we have 2 solutions, we have to check for what's called extraneous solutions. They're kind of called like trick solutions. They look like they work, but they don't. So if you get more than one solution, plug them back in to check and see that they work out. So plug in and check for extraneous solutions. And if it's extraneous, it won't work when you plug it back in. Okay, so we're going to solve first. We're going to solve radical x plus 6 equals x. So I already have the radical by itself on that left side, so I'm just going to start by squaring both sides. Well, when I square it, the radical cancels out, so I just have x plus 6 on one side. Well, then I have x squared. So now I want to get 0 on one side, because how do I solve something with an x squared? I'm probably going to want to factor it. So I'm going to subtract x and subtract 6. So I get 0 equals x squared minus x minus 6. So I need to factor. Well, what adds to negative 1 and multiplies to negative 6? It's going to be a negative 3 and a positive 2. So I have x minus 3 and x plus 2. So now I need to solve x minus 3 equals 0, x plus 2 equals 0, add 3, x equals 3, subtract 2, x equals negative 2. So your answers are 3 and negative 2. So I think my answers are 3 and negative 2. Let's substitute in and check. So I think they're 3 and negative 2. Let's plug back in a 3. So it's radical x plus 6 equals x. So 3 plus 6, and I want to check that it equals 3. Well, that gives me radical 9 equals 3. That works out. Here, now I want to plug in negative 2. Negative 2 plus 6 equals 3. And that'll be a radical 4 equals 3. That doesn't make any sense. No. So your only solution is 3 because negative 2 is not a solution. It's extraneous. That's our word for that. Let's do another one like that. I have radical x plus 11 equals 0. So I need to subtract 11 from both sides. So I get radical x equals negative 11. Now I can square that radical x and square the negative 11. Square root and a square cancel out, so I just have x. Negative 11 squared is 121. So now I need to check, and I think 121 will work, but let's check. So I should have radical 121 plus 11 equals 0. Well, radical 121 is a positive 11 plus 11, which does not equal 0. So that is not a solution. So you would write no solution, just like it has there. So they're a rare one because you only had one solution, and it worked out to be no solution. So I usually only check if you get more than one solution, but if it's going to throw us some of these curveballs, I'm actually going to edit that. I'm sorry guys, and I said should just always check. So we're going to always check. You can usually do a mental check. I'm sorry. You can kill me later. You can blame me. Miss McMillan's getting tired. It's one of our last videos though. Woo! So always plug it back in and check. But usually if you have one, it's going to work out for you. It's when you have two that it's going to be kind of confusing. Okay, so I'm going to have you do number 2, and let's do number 1 together here. So I would add 13 to both sides to get my radical alone. Radical x equals 13. I'm going to square both sides. Square and the radical cancel out, so I have x equals 169. Not sure where this went. And so now, if x equals 169, I can check that. So I'd have radical 169 minus 13 equals 0. That gives me 13 minus 13 equals 0. That works out. That's my solution. Let's try number 3 together too, and I'll let you try number 4. Okay. Remember, even sometimes if I give you stamps, because I don't notice if you haven't done these, when you turn your packet back in, you do get Dachshund points. So make sure you're doing those. So I'm going to subtract 2 from both sides. Even if you're confused how to do it now, make sure you come back to them, because I will dock you points if those aren't completed, even if I do give you a stamp. So I'm going to subtract 2 from both sides to get my radical alone. So I have radical 4x minus 8 equals 4. I need to get rid of that pesky radical, so I'm going to square it. And goodbye radical, it cancels out. So I just have 4x minus 8 equals a 16. So So I'm going to add 8 to both sides. You get 4x equals 24. Divide by 4. And you get x equals 6. It should work out, but let's triple check. It was radical 4x minus 8 equals 6. So radical 4 times 6 minus 8 equals 6. So radical 4 times 8 is 24 minus 8 equals 6. Uh-oh, radical 16 equals 6. Unless Miss McMillan did something wrong, this is a no solution. Which I think she did. I thought 6 should work out first. Oh, plus 2. That's what it is. I knew this worked out for us, guys. I'm really losing my mind today. I should edit all this out, but I don't know how. So that's okay. So there should be a plus 2 on all of these steps, which means radical 16 is 4, and plus 2 does equal 6. There's a plus 2 on there. Forgot that little plus 2. So x equals 6 is our solution. And it does check out when we plug it back in. So now geometric mean is our last little concept, and it's not terribly important, but it is something, not something on your final, but something that I think we should just quickly go over. So the geometric mean of a number, it's just a fancy word for saying radical of both numbers multiplied together. So if you multiply two numbers together, take the radical, that's a geometric mean. So if I have the geometric mean of a, which is we don't know, it's a variable, and 4 is 8, we want to find the value of a. So our geometric mean is the 8, and then I have a times b. Well, I don't know my a, but I know my b is a 4. Well, now I can solve and find that a. So I'm going to have to square both sides. So I have 8 squared and radical 4a squared. Well, those all cancel. So you have 64 equals 4a. Divide by 4. Then you have a equals 16. Not too bad, right? So you just have to know geometric mean is the square root of two numbers multiplied together. That's all it is. Yay, vocab. So let's do one more. So again, it's your geometric mean, we'll call it g, equals the square root of a and b. So we have 6 in a, so we have radical 6 in a, and their geometric mean is 18. So I can square both sides here. So then I have 6a equals 18 squared, which is, let's see, not 164. Let's look. Sorry guys, momentary pause here. 324, that's what it is. So I'm going to divide by both sides by 6, which gives me a is equal to 54. So go ahead and try number 6, and you are done with tonight's notes. You only have one more video of algebra left ever. Wow, exciting.